Hello, Dan. Hello, Nikki. It's Monday. Monday the 17th, only 2 days after I made my last video. And gosh, it seems like I've got a lot to say. There's actually a specific thing I want to talk about, but I'll do a little rambling first if that's okay. I've had a cold. The gods have punished me for all the open water swimming. And I finally got one. So I am now sitting in the purple room, which we call it the purple room because it is purple. Yes, I know. Very novel. This is Duncan and Galen's old room, which is now going to be our study. Which is where you come to study. So I've just got the trim left to do in here, then we'll be done. Well, I've got the floor left to do too, and the trim. So I've got a lot left to do, I guess. So Dan, I guess I can respond to a couple of your videos. I would love to respond to some of Nikki's videos, but there aren't any. So I'm thinking it's time for a little haiku smack again. So we'll see. The MLS final, I watched the highlights from it. And yeah, you're correct. I think that Tallywhacker, is that what his name was? Was Houston? The goalkeeper. Anyway, yeah, I think he clearly fouled. What I don't understand, though, is why. But I guess you see it in all professional athletics. The professing of innocence, well beyond the initial frustration. I don't get it. Anyway, I guess I can understand you not watching it. Actually, I think that going out Christmas tree hunting was, frankly, going out with Scott, or as you say, Scott Fairley, my neighbor. Going out with Scott is I think that's a better use of, a better spending of your time than sitting by yourself anxious in front of a television. So, I don't like watching sports by myself if I'm just sitting watching. So I don't watch a lot of soccer. I watch football on weekends, but I'm usually always doing something else, remodeling or something, just to keep myself busy. But I think that's also why I've stopped, really many years ago, stopped rooting for one team. Still occasionally it's hard, it's like, you see Tom Brady and the Patriots play and it's like, oh God, it would be great if they lost. But, they were down, the Patriots were down 31-3 last night and they came back to tie it 31-all. And part of me was like, well, you know what? I mean, if they can do that, then regardless of what his attitude was like, they deserve to win the game, certainly. They didn't end up winning, but still. You see my point. So that's soccer. What else? Cabaret stuff we talked about in the last video. Nikki, we got your Christmas card. It would be nice to see pictures of you and Mike, too. Not just the girls. Why do people do that? We got another card today of just their children. It's like, well, I don't even know they're friggin' children. Well, I know you're friggin' children, but it's like, I want to see pictures of my friends, not just my friends' kids, who I, maybe have met one time when they were little kids. You know what I mean? I want to see, oh, this is cool. I'm going to show you this. Okay, wait for it. Isn't that great? Smog and his brothers. Instant burner. Which you probably figured out. So anyway, send me a Christmas card, but I want pictures of you guys too. Don't just send me pictures of the kids. So again, where did that start? Why do we think that all of our friends only want to see pictures of our children, but not ourselves? Is it because they represent hope and they represent possibility, whereas we're sort of at the end of our lives, or what is that? What does that mean? But really, I do appreciate the card. Thank you. Let's see, Dan, what else have you been doing? Working out. I've really cut back on my swimming. I may be swimming, before Galen died, I was swimming 25,000 yards a week, and now I'm swimming 5,000 if I'm lucky. I have been going to a spinning class every Monday night, and that I enjoy, and that's at the Y. It's a group class, and it's a good cardio workout. I really like it. Let's see, what else? Well, I'm already 6 minutes in this video, and I'm not even started talking about the topic I want to talk about, and that's mathematics. A couple of things I wanted to talk about. The first one is I have a friend named, a friend, I guess an acquaintance really, he comes into the coffee shop, named Felino Pascal. He is a Filipino, and he's a mathematician at Winona State. And he dropped off an article by a Russian mathematician who wrote about trying to teach a group of 6-year-olds math and what to teach them. And really his conclusion was, why teach them something at 6 that they're going to struggle with and that you're going to have a hard time getting them to understand the ideas behind, when at 8 they can learn it in 10 minutes. So, but it was a really interesting article. Actually, I'd love to forward it on to you guys because I enjoyed it a lot. But really, that's not why I'm making this video either. I came to talk about the draft. No, wait a minute. That's Alice's restaurant. I came to talk about mathematics. More mathematics. So, Nikki, you were not privy to the conversation that Dan and I had about factoring polynomials. Dan referred to them in his last video, but I just, I was going through a math sheet with Marshall, and we were factoring polynomials, and I was really loving it, but I was starting to see it not as just math, but more as, puzzle and pattern recognition. And I really was getting into it in a way that I never did when I was in high school. I can remember going through some of the stuff in physics class and really enjoying that. Really enjoying figuring those puzzles out. But I don't know, it seems different now. Maybe it's just because it's 40 years later. But I had made reference to Luco, who was my algebra teacher, and Dan's algebra teacher when we were freshmen. That was our first trimester, I think. And I never paid enough attention to actually get it. All I was frustrated most of the time. And so it just feels so different now going through it. But when I was a police officer, one of the things I used to do whenever I went to training, and Dan, you might want to try this when you go to your meetings, is I would try to derive formulas sort of intuitively for the volumes of solids. And, of course you started off with your regular cylinder, and that's, pi r squared times the height, right? It's just the area of the circle, that bottom of the cylinder form, bottom of the cylinder. and multiply it by the height of the cylinder. It's pretty easy, right? So really what you're doing is you're simply taking the area and you're adding all of those little areas up for that whole height, right? So I started thinking about that. And started thinking about, okay, so how would I do that with a cone? And I was like, okay, if I can't take the area of the circle on the bottom of the cone, and because it decreases as you go up to the point at the tip, right? So that wouldn't work. And I thought, well, maybe if I could take a cross section of the cone like this. And what if I rotated it around that vertical axis? What I could do is I could take the height, or I could take the area of the rectangle, the area of the triangle, and I can multiply it by the circumference. So the area of this triangle is essentially 1/2 the height times the base, right? Because it's half of a rectangle. So 1/2 the base times the height times the circumference, which is what's that? The circumference is 2 pi r, right? So 1/2 the base times the height times 2 pi r. It doesn't work. What I end up with is the volume of the cylinder again. So it's like, well, that doesn't work. So I couldn't figure it out. So I went and looked up the formula, and so it's actually 1/3 of the volume of the cylinder. That if this bottom, was the radius of that cylinder, that would be what am I trying to say? It would be 1/3 of that radius, or 1/3 of that total cylindrical volume. So I thought, why 1/3? And I've been trying to figure out for probably 17 years. Just every now and again, every year or so, I think about it, and I think, okay, 1/3 of the volume of the cylinder. Why 1/3? 1/3 is just so clean. And I've asked a few people over the years and never really got anywhere with it. But I had the brainy idea of asking a physicist. His name is Nathan Moore. Nathan comes in and trades eggs for coffee with me at Mugby. So I said to Nathan one day last month, I said, Nathan, why is it 1/3 of the volume of that cylinder that bottom would form? So if we took this triangle and we rotated it around this vertical axis, and we took that circle that was scribed by the bottom and made that into a cylinder, why is it 1/3 of that for the volume of the cone? And he gave me some answer, but it wasn't clean. It didn't make any sense. So later that day, I ran into a friend of mine named Steve Leonardi. Steve teaches mathematics at Winona State. He's got a son who was fairly good friends with Galen, named Ben. Ben and I Ben's also willing to go up and do backflips off the rope swing, which is kind of cool. And I tried to teach him tried to talk him into doing a double backflip. He ended up kicking himself in the forehead. So that was not good. Anyway, so I asked Steve, and he said, it's funny because somebody just asked me about that today. And I said, it wasn't Nathan Moore, was it? He's like, yeah, how did you know? And I said, well, because that was me asking Nathan about it. And Steve was like, well, I'm going to have to go look it up, and I'll let you know. It's like, okay, that's cool. So he went and looked it up, and he found an answer. And here's what he brought me. So, here's the deal. Here's the question he posed. He said, is there a simple explanation for the fact that the volume of a right circular cone, i.e. an ice cream cone, equals 1/3 the volume of a right circular cylinder? So essentially the volume equals 1/3 pi r squared h, right? Pi r squared is the, anyway, you know what I'm talking about. So the answer is Pappus's theorem. There's a guy named Pappus. He was a mathematician, or a philosopher really, in 300 AD. He was Greek. In fact, a little aside, he also had theorized some stuff about the motions of planets, which of course the early Christians didn't like at all, and so they ended up sort of doing this campaign against him, and it became known as the Great Pappus Smear. So anyway, and so the theory was, Pappus theorized the same thing. He said, now, his part of this is like, okay, if I take a volume of a solid that is essentially a revolution around a vertical axis of a two-dimensional object, how do I come up with that volume? So what he came up with is just like, okay, let's say I start with a rectangle. Let's say I start with this. And this is the vertical axis, and I rotate that around. Well, we all know that's going to be easy, right? It's going to be pi r squared, which is the volume of that circle that it describes, times the height. Easy enough. But here's what he came up with, which is really kind of cool, because you can apply it to rectangles and cones. To triangles and cones. So he said, okay, what I have to do is if I take the area of that rectangle, then what I have to do is if I multiply, how did it go? 2 pi r is if I multiply the radius times the height, which is the area of that rectangle, and I multiply that by 2 pi, and I multiply that by the radius, then that should give me the volume of that solid, except that what you realize is you have to multiply it not by the radius of the radius of the whole thing, the radius of the bottom, but you have to multiply it by the centroid, which is the center point. Does that make sense? I know I'm talking really slow, and I'm trying to think about this stuff. So you got to multiply it by the center point, which is called centroid, of a two-dimensional object. And so if you take the centroid, which is, of course, in a rectangle, is going to be half of that radius, and you take that and you multiply essentially the area of the rectangle times 2 pi half of r, half of that, then that's going to give you the actual volume of that cylinder that it forms. Now, you think, well, why go through all the trouble? Well, here's why. Because then when you apply it to a cone, the question becomes why is it 1/3, right? Why is it 1/3? Let me tell you why it's 1/3. Because when you take a centroid of a triangle, in order to find the centroid of a triangle, what you do is you take straight lines from each intersection or each angle to the middle of the opposite leg, here, 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 and here, here, then that point that it forms where they all meet is the centroid of that figure. That centroid just so happens to be this distance is 1/3 of this total distance. This distance is 1/3 of the total height. So in order to, if we take this figure and we, like I said, I thought, well, why don't we just take the area and multiply it by the circumference? Well, you can, but you got to divide that circumference by 3, because you're actually multiplying it by the circumference of the centroid of this centroid point. So this circumference, as that goes around, that's what you're multiplying it by. So it's only 1/3 of that total thing. So it's actually half, right? Half of, what is that? Half of the height times, let's call this r, for lack of anything better. Half of the height times r is the area, and you're going to multiply that by 2 pi r divided by 3. That gives you the circumference. So the 2's cancel each other out, and you end up with pi r squared h divided by 3 because of the centroid. And I just thought, after literally 17 years of thinking about this again and again and again, I finally have an answer, and he wrote out a whole little theorem. Let me see if I can get it up close to you. I mean, I know this is a really long video, but this stuff's exciting. Can you see that? See how exciting that is? Get excited about math, people. I just love that. So anyway, Steve Leonardi, I love you. And I guess with that, all I can say is go USA.